Hello everyone, this is lesson 7.6. We're on page 243 and we're talking about how to find the exact number of holes. Or I guess rather the question is, do we have an exact number of holes? We're going to be working with improper fractions today, I think for the most part. Yep, they're all improper. And I'm going to throw a few examples at you and then I'm going to let you tackle page 243 on your own. So here's what they're throwing at you. They're throwing you an improper fraction, which means a numerator is greater than the denominator. So let's start with a number like 13 fourths. And their question is, would this make a perfect number of holes? So let me walk you through what they mean. I'll walk you through with a drawing. And you'll notice with fractions, a lot of it is visual, a lot of it is drawing. So what if we literally made or drew 13 fourths? If you have fraction pieces, you could use those, but I don't think I sent those home. So you might be left with making your own fraction circles. So that means if we're working with fourths, that would be like a whole piece that is broken into 4 pieces. So how many fourths do we have in this first hole? Well, 4 fourths. So we've made 4 out of the fourths, and remember, here's our target. We want to make 13 of the fourths. So do we need more? We do, because we only have 4 fourths so far. So we'll make another, and this will be another 4 fourths. And how many fourths do we have total? 1, 2, 3, 4, 5, 6, 7, 8. So we're almost there. Okay, we have 8 fourths so far. We still have room for another hole, I believe. So another 4 out of 4. 4, 8, 12. So we have 3 perfect holes so far. So 12 fourths is a perfect hole. But again, we need 13. So that means we're going to have to make one more fourth piece, which is going to look kind of like this, I think. I'm trying to make a fourth without making the rest of the circle. And this would be 1/4. Okay, so we have one entire piece, which is 4 fourths, a second one, which when we combine them makes 8 fourths, a third hole, which would make 12 fourths, which we're so close to a perfect number, exact number of holes. But we needed one more fourth to get to 13, and here he is. So the question we're going to ask now is, do we have an exact number of holes? Is it just holes all the way through? Here's a whole pizza, whole pizza, whole pizza. And if you look, it's not, because we have a piece left over. It's not a perfect set of whole numbers here. So 13 fourths would not work in this case. I'll show you a quicker way, which some of you will probably like facepalm, be like, well, I wish you would have told me that right away. If you're not interested in visualizing and drawing the pictures, you can take the division route. If you want to see if it's a perfect whole, ask yourself, how many times does 4 go into 13? Or also known as, what is 13 divided by 4? And some of you may be able to say, oh, well, 4, 8, 12. So 4 goes into 13 3 times. And how much is left over? We can get up to 12, but we can't go any higher, right? Because we'll go over. 4 sets of 4 is 16. That's too much. So we can get to 12, but we'll have 1 left over. So 13 fourths is equivalent to 3 holes and 1/4 left over. So we can tell just through division that this is not an exact whole. Let's try a different one. We'll try 16 fourths, just to show you what an exact whole may look like. And I already gave it away. I told you right away that this will work. This is one that would be an exact whole. Now I'll speed run the drawing. 4 fourths, 8 fourths, 12 fourths, 16 fourths. Okay, so we have 4 fourths, 4 fourths, 4 fourths, 4 fourths. You notice how my quality of drawing drops when I don't take my time. It's true for most people. So 4, 8, 12, 16, that's our magic number. Are there any leftover pieces? Almost said pizzas. Are there any leftover pieces over here? Like another fourth, a second fourth or something? There's not. We got right to 16 by only using entire fraction circles of fourths. So that means this would be an exact number of wholes. And we can check it with the division route. 16 divided by 4. So how many times can 4 go into 16? 4, 8, 12, 16. 4, 8, 12, 16. It goes in 4 times perfectly. There's nothing left over. It hits 16 right on the dot. So if we have no fractions left over, you notice, remember we had the fourth left over up here? Nothing like that down here. That means this one works out just fine. This would be a yes. And this, in contrast, would be a nope. So what you're going to do on your actual page here, let's get that out of the way. Does this fraction make an exact number of wholes? So you're going to go through A through F and answer like, hey, does this make an exact whole or not? And then you'll need to explain or show why or why not. So you can either use words, or if you want to use the drawings that you saw in my example, that works too. You could even use like a number line if you wanted to go that route. But long and short, will it be an exact fraction? Show me how you know it. All right. Any questions or comments, let me know through email, through YouTube, through Dojo. Is there anything else out there? I think that's about it. Google Classroom. That works too. Elsewise, I will see you for 7-7. Goodbye.